Hello and welcome to The Urbanist, Monocle's programme all about the built environment. I'm your host, Andrew Tuck. Coming up.
I still believe that all this negative chatter is chatter and the energy transition is still underway, and we have to keep focused on what we believe is right, is getting as much of the technology out there as possible.
This week we discuss some of the ways that heating the air and water in our buildings can be made greener, from an innovative solution to capture warmth that would otherwise be wasted and redirect it into our homes, to a solar project in London that is decarbonising the water heating process for one of the city's heritage institutions. Speaking of water, we visit one of India's historic stepwells to see how the ancient structures could provide an answer to the country's water supply woes. That's all ahead in the next 30 minutes right here on The Urbanist with me, Andrew Tuck. We begin today in London's Southwark area, where one new development is seeking to change the way in which heating is being used and reused. The innovative heating system will contribute to the project's aim to become the UK's first major mixed-use development that is fossil fuel-free in operation. It's Bankside Yards. Felicity Macefield is a director at the London-based property developers Native Land, the firm behind the development at Bankside Yards. She recently joined Monocle's David Stevens in studio to discuss this novel way to reuse warmth. And David began by asking Felicity to define what we're talking about when we refer to waste heat.
Waste heat is energy which is produced, but it's not used for its intended purpose. So essentially it's excess waste. This can be created from different things, such as just industrial processes, transport, car exhaust, for example, but also buildings produce a lot of waste heat through the cooling and heating of them. And increasingly, there are ways that you can capture that waste heat and utilise it. It's estimated that across Europe, if we could capture all the waste heat, we'd be able to power about 90% of residential buildings across the EU and the UK. So there's this huge potential to utilise this essentially untapped energy resource. By capturing this waste heat, what you're able to do is reduce the amount of energy that is required. So that is then reflected into lower energy bills and lower energy costs for the occupiers or owners of a building, for example. So that is, really welcomed in the current environment where the UK is seeing significantly higher energy costs than the historic average. But I think there's also other benefits to capturing the waste heat. In addition to lowering costs, it's going to play a huge part in actually the decarbonisation of these systems in the future. Using less energy also means, emitting less carbon emissions as well.
Simple equation, really.
Yeah.
So we're going to talk a little bit about one of the examples of how you're doing that in Bankside in a moment. But maybe more broadly, what is the process for doing this? How do we capture this potential that we know is there and we know can lower costs? What's the process of actually capturing this?
Yeah, so there's a number of ways, and this has kind of developed over time. If I kind of start back probably in the kind of late 19th century, where you had the combined heat and power plant, also known as a CHP, which allowed electricity and heat to be generated from a single energy source. So as you're generating energy, you're able to take the heat created from that and turn that into heating. That then was able to be expanded around the 1960s by using district heating networks. The first of that in the UK was actually Battersea Power Station. So the waste heat from that was able to be captured and utilised and able to heat actually thousands of homes over in Pimlico across the river. And we're continuing to do things like that across London. More recently, we're using data centres, for example, to take that heat and power homes and schools and businesses, or waste heat from, the Northern Line, for example, as well in our transport. But that technology has actually gone even further now. What I've just referred to is typically uses fossil fuels. You would call it potentially a third or fourth generation energy network. And what we at Native Land are implementing on our development in Southwark is a fifth generation energy network.
Can you explain those generations a little bit more?
Sure. So third and fourth generation energy networks is kind of the standard network which we have currently, mostly kind of across the UK. They will typically run on fossil fuels. They will probably do heating and cooling separately as well. And what we are looking to implement at Bankside Yards, which is a development which will be 8 buildings. It's in Southwark, right by the Tate Modern in London. And there will be workspace, homes, cultural use, shops, restaurants, a Mandarin Oriental hotel, and extensive public realm. We are using a all-electric, low-temperature, fifth-generation energy network. And that's really exciting because that's an integrated heating and cooling system. So the system's able to absorb waste heat and extract and reject it using heat pump technology around the site. So all of the buildings, once it's complete, will all be connected by this system. And it makes it extremely efficient because having the different uses especially, you have the residential apartments, which typically in the mornings and evenings have their highest energy demand, and then the offices throughout the day. There's also the movement of energy from, say, office air conditioning, can then take that waste heat to the residential or the hotel, which typically have a really high hot water demand. So the energy is constantly flowing depending on the demand. So you have very, very little energy which is actually wasted. And a key part in this network is also the low temperature aspect of that. We will be running on about 20 degrees Celsius. This is significantly lower than your typical standard network, which would be much higher, probably around 70 degrees or so. So this means that when the waste heat is absorbed into the network, it can be absorbed kind of straight away directly into the system, rather than the standard third or fourth generation energy network where you would have to actually upgrade that waste heat to the higher temperature, which uses more energy in the process. But also you actually require additional kit to do that as well. So you are going to have extra embodied carbon, which is the carbon from just having extra equipment from construction.
Do you think the conversation's changing a little bit? You know, in my mind, it used to be these things, these sort of systems were nice to have or very worthy for investors to show their audience that we're doing the right thing. Do you think the conversation is changing now where people are understanding that actually there is saving to be made while also being better for the planet?
Yes, I think coming back to your question around the cost, I think anywhere at the moment where you can essentially save cost for the end user as well is, you know, really welcomed across whether that's residential or commercial or hotels. So I think, you know, it's a really exciting technology which is being, you know, looked at increasingly in the UK. So at Bankside Yards, it will be the first in a mixed-use site of that scale. Others are starting to use it as well. But, you know, it's not a new technology in the north of Europe, particularly Scandinavia. They are, you know, using this technology more widely than us.
And do you think that's because the technology has improved or the way we talk about it and present it has improved?
Yeah, that's an interesting question. I think there's a bit of a crossroads when we developed our district heating networks. That's when Scandinavia took hold of that and really ran with it, and we went in another direction, I think, as a country, and actually we're developing out our gas infrastructure more. So hindsight's a great thing to look back on that now, but it's coming round again, and we're now learning, you know, from Scandinavia and its education and collaboration and, you know, sharing knowledge for people to implement this technology themselves.
I was going to ask about that. Do you think the UK is best placed to implement this? You know, if there's a developer that really wants to do this and they're in Manila or they're in Egypt or the US, is there places where that's just kind of asking for this sort of technology to be implemented, ready to put it in?
Yeah, I think there's lots of opportunities. The UK's, definitely not leading the way on it, but, you know, it is starting to come through, which is really exciting. The UK government, you know, is increasingly showing interest in utilising heat networks in general and have recognised the benefits of capturing that waste heat. So that is coming through, albeit probably a bit late. It would have been nice to have done that sooner, but great it's happening now. I think at the moment we have 3% of our residential buildings in the UK connected to a heat district system. The ambition from the government is to make that 20% by 2050. But if you look at, you know, Denmark, for example, they already have 65% of their homes connected to a district heating system. So we are significantly behind other countries.
Leading the way, though, you
Yeah.
are at Bankside Yards. Tell us a little bit about that development, what you're doing at Bankside Yards, even outside of the heating situation. What's going on there and what's exciting for you about that development?
Yeah, so it's 8 buildings. It will be the UK's first major mixed-use fossil fuel-free development. So it's an all-electric system, which is also, a benefit to the energy network, and all that electricity will be run on renewable energy sources. So it'll be net zero carbon in operation, which is really exciting to be doing on such a great scale. We have offices, the Mandarin Oriental Hotel, which will be coming onto the site as well, which, is really exciting, as well as just the general public realm. So there's 5.5 acres, and about 3 acres of that will actually be public realm as well. So we're looking at being able to give back to, the community as well.
Felicity Macefield there in conversation with Monocle's David Stevens. Next up, we head across London to the British Library. This Grade 1 listed heritage building has recently completed the installation of a rooftop solar project which allows the building to generate its own heat and electricity, reducing emissions as well as protecting the institution's priceless collection of books. The firm behind the technology is Naked Energy, and I'm joined now by Christoph Williams, the company's CEO. Christoph, thank you for joining me. Can we start by just outlining the scale of this project that you've recently completed?
The British Library really is the biggest project that we've ever done, and it's actually the biggest project that's ever happened for solar thermal in the United Kingdom. It's quite unique in its application. We have installed nearly 400 kilowatts of solar thermal and PVT, which is hybrid solar thermal and PV, which is a unique product that we've developed. And the library application, because you probably think, well, what does a library need all that heat for? And the core application is sanitary hot water for the staff quarters, the taps and showers, but also space heating. And the additional thermal energy we generate goes into a dehumidification process, which is quite interesting, where the thermal generation drives a silica gel process, which controls the moisture where the precious manuscripts are kept in the library. So things like Shakespeare's First Folio, copy of Magna Carta, some extraordinary manuscripts, and we're doing it contributing in a renewable way from the solar thermal array on the roof. I still pinch myself when we drive past or I see the array on the roof and think that's our technology helping such an iconic building.
Solar thermal, just for some of us who are not so versed in it, I presume solar panels, but the thermal part, what's the difference between this just being a solar project, for example?
Sure. So you typically have 2 types of solar panel. When someone thinks of solar energy, they probably think of a normal PV panel. That's photovoltaic energy.
These are the things we see on the top of individual houses, maybe, or propped up in a field, for example.
That's right. They're quite ubiquitous and they're very common, predominantly manufactured in China. They're effectively a commodity now because billions upon billions of money have gone into developing that supply chain and getting the cost down. So you have typically a solar panel that produces electricity around about 18% efficiency. So it takes sunlight and converts it photovoltaically into power. That then can be used in the building for appliances, any electrical use. It can be converted from DC to AC. And the other type of panel is a solar thermal panel, which is less well known and quite overlooked. What that does is it uses the heat from the sun, so that's the radiation as well as visible light, to warm a surface. So it's a dark surface, it's very benign, it's very pure, very simple, and it uses the majority actually of the sun's energy and converts it to warmth. So it heats a liquid that is flowed through there, which is typically water. And so you're heating water from the warmth of the sun, and it can do it up to about 80% efficiency from the sun's energy, which is really interesting. So it can heat water up to 100 degrees Celsius for certain applications, or it can even heat it where you have concentrator-type solar collectors that can go to many hundreds of degrees Celsius. But those are typically the 2 types of solar collectors. Ours are tubular, the design that we have. We don't call them panels, we call them collectors. It's a tubular design that actually inside the tubes we take the air out, so it creates a vacuum, and that means even in cold climates like the UK, and for example the British Library, we can generate meaningful heat up to 60, 70 degrees Celsius, even when ambient temperatures are down at, say, 10 degrees. So long as you have some sunlight and radiation, you can still generate useful energy.
Why did the British Library want to be an outlier and do this project?
That's a great question. I think they are an iconic building. They're very progressive. They do have an enormous energy bill in terms of power and gas. They do have very large gas turbines, boilers in the building, and they want to become more energy independent and reduce their on-site consumption. And the array that we've installed displaces 55 tonnes of carbon per annum, and it takes a surface area of 715 square metres. So that's really impactful. There is much more roof area we could go at, but that typically will reduce a very significant portion of their on-site emissions.
Because interestingly, the library moved from the British Museum where the reading room was. It went up there some years ago now, but it is in a sense a more contemporary building with flat roof surfaces. So was it actually a good building to test this technology on at this scale? Because maybe people aren't going to be so up in arms about you bolting onto a Georgian building, for example, and then people are a bit more understanding about its use.
Well, that's really interesting because actually it was very challenging to get any technology on the building because it's a Grade 1 listed building, and England Heritage had declined all solar products going on the building, and it's overlooked by the St Pancras Hotel and many other buildings in the area. Our product was the only solar technology that was allowed by the planners and England Heritage.
Is that because it's not so visible when you're up above? As you say, it's on a black background as well. Is it less obvious?
There's a few reasons. The principal one is low visual impact. So the collectors are designed, we've designed them to be very low profile. So on a flat roof, they're only 26 centimetres off the roof line. So they're very low profile, which reduces visual impact. Also being cylindrical, we had to do a lot of glint and glare studies for the local planners to show that we're not going to be bouncing light back into other buildings, whereas a flat surface on a normal panel would do that, depending on the sunlight. So all our light is captured and goes into the collectors. Also wind shear, by being low profile, it means that there's less wind resistance on the panels. It acts like a sail. If you think of a normal flat panel, it's like a wind sail, it catches the wind. Ours are tubular and lower profile, so it actually puts less stress on the building. So those three factors really were the differentiator, and we worked with our installation partner, Convert Energy, who really helped design and install the system for us, and CBRE, who are the principal contractors responsible for the project.
You talked about energy independence. How independent does it make them from being plugged into the wider grid?
The British Library is an interesting use case. It's not, say, typical of where we focus as a business. We like to focus on commercial industrial applications where they have an all-year-round hot water demand. That is, say, hotels, hospitals, manufacturing industry, say, food and beverage. The British Library is quite unique in its topology. It's 9 floors and it has an enormous demand. And so the installation that we have done, it will remove about 5% of their total gas demand, but that's only the roof area that we've used. We can actually scale that up. If we used all the available roof area, it would be about 40%. So much greater potential. So this is, you could say, phase 1, and we could do a bigger impact. But when you look at a typical customer, say a manufacturing site, food and beverage, they have a flat demand for heat. And a lot of their heat is low-grade heat. That's below 100 degrees Celsius for sanitization, cleaning in place, things like that. And they're typically using steam, because when we had very cheap gas from the North Sea, all this steam infrastructure was put in place. But actually, they only need lower-grade heat. So what you can do with our technology and solar thermal is we can provide 100% of their heat demand in the summer. That's 3 to 4 months and a bit in the shoulder seasons. But when you annualize that, that can be anywhere between 30 to 50% of their total demand on those types of applications. And when you look at the current climate, energy prices going up because gas prices are going up, and we're using gas to create power. Imagine if every single manufacturing site, commercial facility, public sector building that had a high heat demand, like leisure centres, for example, had solar thermal sized correctly to provide 100% of their heat. We would massively reduce our need to import gas. So it's something that we can see the North Star, we see the potential for solar thermal, but it's a technology that's really been overlooked, particularly in the commercial industrial space. It was very popular in the residential space when the Green Homes Grant was there. Actually, the uptake was greater than heat pumps, but it's been majorly overlooked in the UK, unfortunately.
So you started your company in 2011. It's called Naked. I'm not sure if that's to do with the ambition or kind of, you can maybe tell us about that. But what's your feeling about where we are? Because, BP have announced that they're going to be going back to oil exploration and gas exploration because they don't think they're paying big enough dividends to their shareholders. We're seeing a conversation changing in the US around the environment and sustainable energy sources. But do you feel, despite all the noise at the moment, that we will continue on this path? Because, as you say, it saves companies money in the end.
That's right. I've seen a lot of trends and changes. As you highlight, this has been a joke. It's a 10-year overnight success, to get the company to where it is. We've been on a long R&D journey, and now we're commercialising and scaling and doing some really nice projects, not just in the UK. We're very much internationally focused. We've now sold into 9 different countries. We are setting up manufacturing in the US.
Just on that, you're the manufacturer as well as the provider, as well as the installer. You're kind of end-to-end almost, are you?
We're not totally end-to-end. We are the technology owners, so we've developed all the IP. We've got about 24 patents, and we've got some brilliant scientists and engineers in the company. Naked Energy, to answer your question, it's really about, I guess, naked ambition. Our first article on us ever by Business Green was about naked ambition. But naked really, for me, it's about purity. It's when you strip things back in its purest sense. I see solar thermal as such a pure technology. You stand in front of the sun on a cold winter's day, you can feel the warmth, and we just want to utilize that warmth to help commercial and communities decarbonize affordably. And so, it's been a long journey, and I've seen different trends. When I first pitched to investors about, hey, this is a great idea, and I left the advertising world, I think quite a successful one, doing some really exciting projects to start a clean tech startup. When I first pitched to investors and said, hey, look at this, they were just not interested in the carbon savings. They said, what's the ROI? What's the economics? It's the green in the pocket rather than the green initiative. And slowly that's changed. There's much more sort of impact investors and investors realizing. And so there has been a big uptick. I think a lot of investors got burnt initially, and so there was a lot of bad press about it. But climate change is not an overnight success. This is, the transition is happening. And the cost of energy, the cost of renewables, it's got grid parity in many parts of the world. It's a better economic choice, as you said, versus the carbon choice is very good. You want to help with the environment, but actually in many parts of the world, it's lower cost. And so, yes, there's a backdrop at the moment about all this sort of pulling out of net zero goals, and there's a lot of, I would say, backward steps. But I think having been on this journey a while, I really see that the energy transition the train has left the station, as we say, and it's a better economic choice. And I think what's really happening now is we set out as a company to decarbonize heat. And that's our mission, is to get businesses and communities off gas with our distributed solar heat energy. And that is becoming the sort of big elephant in the room. It's like, how do we decarbonize heat? And electrification is one of the ways. And I think this is one of the topics, is it's now omnipresent. Heat is a local challenge. You need heat to be generated where it's used, in factories and hospitals, etc. It's now becoming an alarming challenge, and with geopolitical stresses in Europe, gas prices fluctuating and they're going up again, and there's all this uncertainty. The more we can deploy solar heat, solar PV, batteries, thermal storage, and technology to make them smarter and more efficient, I still believe that all this negative chatter is chatter, and the energy transition is still underway, and we have to keep focused on what we believe is right, is getting as much of the technology out there as possible.
My thanks to Christoph Williams there for joining me on The Urbanist. Lastly today, we stay on the topic of water and head to an ancient stepwell in India. Stepwells were common from the 7th to the 19th century, where a series of steps would descend into subterranean reservoirs of pooled groundwater. Today, many believe these ancient features of Indian cities can teach us how to combat our modern water challenges. In 2018, the government of Rajasthan, one of the most water-scarce parts of the world, drew up a framework to restore its stepwells. In this report, Geetanjali Krishna takes us into the stepwell to see how these ancient structures can help with modern urban water issues.
Hot winds blow across Delhi even though it's only early spring, and the summer promises to be even hotter and will no doubt bring with it the city's annual water crisis. In 2024, Delhi needed 1,300 million gallons of water the equivalent of 130,000 Olympic-sized swimming pools every single day. As the city deals with heat and water scarcity, which are only going to become worse in the coming years thanks to climate change, everybody is looking for solutions. And some of these are coming to us from history. Ghostly whispers rising from cavernous, long dry wells that are in sharp contrast to modern Delhi's mayhem. These are stepwells, locally called baulis, which are deep structures with steps that take you underground where water collects in a shallow tank. In the past, people would go to these wells to bathe, wash, and to enjoy their coolness. But today, when you visit some of these baulis, many of which are in the heart of the city, they hark back to a different era when there were fewer resources, and perhaps that's why a greater respect for them.
When I first time visited a stepwell, it was Rajon Ki Bauli of Mehrauli. And I was just walking along that path and I had no idea something exists over there. I just saw a huge wall because there is a protective boundary that Archaeological Survey of India has done. And the moment I reached near that boundary and I saw a gate and I stepped inside a gate, I still was not able to see anything. But there was a huge pit. And as I started walking closer to the pit, steps revealed themselves and it was magical, it was magnificent. And every single stepwell that I have visited since then, you can pass by and you will not even notice that something exists over there, and all of a sudden a deep majestic structure going 30, 40, 50, sometimes even 100 feet deep reveals itself. It's interesting.
I'm with Vikramjit Singh Rooprai, a heritage activist who's written an excellent book on Delhi stepwells and their significance. With his signature white turban and bushy beard, Vikramjit is a familiar figure often spotted amongst the city's historical monuments where he regularly leads walks. And today we are in the south of Delhi, where in a busy neighborhood of government houses, there's a garden with screeching parakeets, 14th century tombs, and of course a stepwell known as Munir Ka Bauli. This is a long rectangular stone structure with weathered stone steps leading down to a tank at its base. Behind it is a well from where water once flowed into the tank. People would drink water from the well and use the tank for bathing, washing clothes, and often simply to find respite from the scorching summer. Such stepwells were common from the 8th to the 19th century all over India, and Vikramjit explains to me how they were used. The tanks were located in deep, dark recesses where the sun could not hasten the evaporation of the precious water in them. Different days were allocated to different activities like bathing and laundry to avoid the cross-contamination of water. And while mornings and evenings were reserved for men, women would come to these wells in the afternoon so that they could bathe undisturbed.
There is this one record that we found which said Delhi at one point had more than 100 stepwells, though we have never found 100. What we were able to trace was about 35, 36, out of which there are 12 odd stepwells that are still accessible and nearly half of them have water. There was a period when these stepwells were being built, and the way they were constructed, the way they were structured, one very important significant thing was a stepped architecture. So one is the steps, general steps leading towards the tank, which gave it its name stepwell. But then there is another level of steps, which is the walls are in a stepped shape where the topmost level would be the widest, and then you will have a platform on which you can walk, and then there would be another further level which will be, the more you go down, smaller it gets.
From the stepwell, it's a 15-minute drive to Agrasen Ki Bauli, another stepwell which is a stone's throw from Delhi's commercial district, Connaught Place. I disturb a flock of parakeets as I enter the stepwell, its weathered stone walls and arches lit by a balmy spring sun. Just like the Bauli that Vikramjit had taken me to, this one also has stone steps that lead down to a tank. And although there's nothing but dirty water and sludge in it today, the steps, still shaded by tall walls on either side, continue to provide a cool refuge. Today they are populated by students from a nearby coaching center, romancing couples, and cooing pigeons in every nook and cranny. I relax on the steps as generations have done before me, conscious of a deep sense of history. But also I wonder, what relevance do these structures have today? A lot, it seems. Many stepwells have been restored in Delhi, and this has caused the water table around them to improve. Some are also being used to divert and store excess rainwater, which is then pumped into tankers and carried to the city's water-scarce pockets. And of course, they're really easy on the eye with their gorgeous niches, balconies, and cool steps. Beautiful public spaces that locals and tourists alike can enjoy. However, bringing them back to life is neither easy and nor cheap. The city's water table has gone down considerably, so many of them will need to be deepened if they have to be revived. Also, their tanks will have to be kept clean by local municipal authorities, a laborious task that was once the responsibility of the local community that used the well. Also, there's no one way to restore them, as stepwells have been built on a variety of terrains and slopes across the country. But wherever they have been revived, there have been improvements in groundwater levels. That's why water experts as well as the Indian government now believe that stepwells could help refill ground aquifers and harvest millions of liters of water during the monsoon. And this could be huge for a country that UNESCO says is the world's largest guzzler of groundwater. In 2017, the Archaeological Survey of India identified 15 stepwells to restore in Delhi. A year later, the government of Rajasthan, one of the most water-scarce regions in India, developed a framework to restore its stepwells. Vikramjit, a great storyteller, takes me back to a simpler time when stepwells were the only source of water for the majority of Delhi's citizens. Today, when taking a bath is a simple matter of turning on the shower, stepwells may seem like anachronisms, but he says they could still play a very important role.
Water has been one of the most precious commodities. Early human settlement was all around water, and all the civilizations that we talk about, they're all river valley civilizations. Since the beginning of the time, other than fire, we have given a lot of importance to water and how to manage water, how to control water. Many of our social conduct, our rituals, our practices revolve around water. And not just in India, but all across the world, all across the religions, fire and water have played a very crucial role. So looking at these stepwells, we realize or we understand that the way they managed water and the way they respected water was amazing.
Meanwhile, the Agrasen Bauli is alive with the cooing of thousands of pigeons. Their deep murmurs echo like whispers and warnings from ancient ghosts. Perhaps they're lamenting past droughts, when men and animals alike perished for the want of water. Or perhaps they're trying to warn us that if mankind continues to use water without coming up with solutions to conserve it and recharge it under the ground, this could be our fate too. For Monocle, in New Delhi, I'm Gitanjali Krishna.
And that's all for this week's episode of The Urbanist. You can follow us for new editions of the show every week. And you can subscribe to Monocle magazine for reports on all things design, architecture and urbanism too. Just visit monocle.com. The Urbanist is produced by Carlotta Ribello and by David Stevens, who also edits the show. I'm Andrew Tuck. Goodbye, and thank you for listening, City Lovers.